Hi everyone, thank you for clicking on this video. In this video, we are actually going to be using the Google Colab notebook, and then we are going to be predicting the Boston house prices. We would be basically using a lot of libraries along the way, which we'll explore in the process. I can show you the overall procedure about how we basically do machine learning. Let us now start the coding in this coding cell, and I can explain you about each and every step. Okay, let's get started. The first thing that we do initially when we start a machine learning project is to upload all the libraries, importing the libraries which are really important for our models. Let us now import those libraries and get started. We just say import numpy as np. We also say uh, we import matplotlib, import cborn as sns. We import scikit-learn because it's a very important library for machine learning. We say from scikit-learn dot model selection import train test split. We should also be taking a look at the dataset, right? The dataset is actually available in sklearn library. Therefore, we will actually take a look at the dataset from the sklearn library itself. Let us import that as well. So if I just say sklearn dot datasets import, I think it should be Boston housing. I think it should be Boston housing. Let me run this. Okay, it's taking some time to load all the important libraries, but I think it should be Boston. Bo- from sklearn dot datasets import Boston. Oh, it's actually load Boston. Okay, yeah, it should be load Boston. Okay, these are the set of libraries that we will be using in this process. Let us take a look at the data set. We just take a variable, we just say load Boston, which is our variable. Here is we have actually taken this instance of the load Boston, and now we take the input values from that. We just say Boston dot data. Similarly, we take the output variable, which is the target, which we're trying to predict in the machine learning model. These are the two things that we do. If you want a clearer understanding about the data, you can basically use boston.descr, which will give a very good understanding about the features we have considered. In this data, we have considered features such as the total crime rate, the total the actual whether it's close to the Indus Valley, a few things like the age of the buildings. Similarly, we do have a lot of other features as well. And finally, after using all of these features, we are going to predict what can be the Boston housing price. If you want further documentation, you can also take a look at this link. But this is how you upload the data from the sklearn library, and we will take a look at that. Right? We have looked at loading the data, which was here. Now the thing is, we should actually divide the data into two parts. We would first train our model with the training data, and then we would expect our model to be performing well, not just on the training data, but on the data that the model has not seen, which is the test data. Therefore, in order to divide the data into two parts, we have an interesting library from sklearn, which is nothing but train test split, which we will use to divide the data. Let us now import that library. So I just say from sklearn dot model selection import that train test split. Now we take the xtrain xtest and ytrain ytest, which we do it in this way: xtrain xtest, ytrain ytest, and we just take a train test split. We give the input, we give the output, we give the total test size, which means that we are taking 30% as the test data, and we basically assign a random state so that the same type of split takes place even when we run when we run this notebook again, right? Now this is how we divided the data. Let us take a look at the shape of the training data. We have 354 rows. Similarly, we take a look at the test data. We have 152 rows, right? Now let us import the most basic library in machine learning called linear regression, and this is how we import it from scikit-learn dot linear, I think it's linear model, import linear regression. Once we do that, we just initialize this with saying that it is linear regression, and then we fit the training value and the output. When we are initializing, we have to fit the models. We fit the model with the training data, and then we also give the output label for that data. The final thing would be to actually get the predictions from the model, which we will do it on the test data. Therefore, we will say y predictions equals to model dot predict. We just say x test to get the model predictions. Now when we look at the predictions from the model, these are all the predictions for the input variables from the x test. Now we'll have to compare how well our models perform on the test data with the actual test values. We have the actual test values which we have earlier taken. These are the actual values for the houses, and these are the predicted values. We can take various error metrics to find out how well we have performed. Let us take a look at 2 error metrics and then finally decide how well our model is actually doing. Right now, I just say from scikit-learn dot metrics import mean squared error. This is a popular metric along with mean absolute error. And then what we do is we take the mean squared error, we give the actual value, which is nothing but y test, and we give our predictions from the machine learning model, which is the linear regression model, to find out how well they're doing. It has a mean squared error of this much. Similarly, I take a look at mean absolute error. I just give y test, y predictions to find out the mean absolute error, which was just 3.83, which means that out of all the predictions, our models are giving just $4 above or $4 below on an average scale. That means whenever our model is giving a new prediction, we can expect that it can make an error of around $4 above the actual price or below the actual price. This is how we actually start a machine learning project. The first thing we do is to import all the libraries. We load the data. We divide the overall data into 2 parts. We train the data using various machine learning models. Here in our case, we just use the simple linear regression, but we can also use more complex models to build a better representation. Finally, we get the predictions on the test data. We try to see how close our models are with the test data. And finally, the last step, which is not actually included here, is to deploy it in real time so that users can actually enter the features that we have seen earlier, and then they can get the predictions about the house prices. Thank you so much for tuning in, and this is about how we start the machine learning journey. If you like this video, feel free to subscribe, and thank you so much for tuning in. Bye.